we're going to do basically review today. So it shouldn't be anything too crazy, but it's going to be a lot of calculator review. So you're going to need your TI-83 or your TI-84 or your TI-80, whatever you got here. If you don't have it here, you're probably going to find this unit impossible. So my suggestion is that you pull it out and get it ready. If you don't have one, sit next to someone who has one. Anybody missing one? Can I see you guys? Are you in? Okay, you can just borrow mine. Do you need one?
Yeah, I need batteries.
No. If anyone needs an extra, does everybody else know it? Gorgeous. Okay. The reason you're going to need that is we're going to be graphing a lot of functions. And we haven't really done any graphing of functions yet. Today we're going to review how we used to graph quadratics and linear equations. Tomorrow we're going to move on to graphing things that are even bigger than that. So the first thing we're going to do, we're going to review some terminology. The first word we're going to review is the word degree. So if we say a polynomial function has degree and then some number, in this case it says degree 0. In this case is degree 1. And in this case is degree 2. Anyone remember what degree means? Yeah, I think it can be affected, the X-Intercepts. It's the highest exponent. So when I say something has degree 0, that means the highest exponent it has on a variable is 0. So it doesn't have an exponent anywhere. Functions that have degree 0 are called constants. An example of something that would have degree 0 would be y equals 2. There is no variable there. There is no exponent on the variable. If I said something was degree 1, that term is called linear. So anything that has the highest exponent equal to 1 means we just have a straight line. Examples of that can be y equals 2x plus 1. Another example could be y equals 5x, or y equals x minus 6. Those are all linear equations because the highest exponent they have on them is a 1. The 1s are invisible, and we don't write to the power of 1, but there is a highest exponent of 1 in each one of those equations, making it a linear equation. Polynomial functions of degree 2 are called quadratics. A quadratic often looks something like this. Highest exponent is 2. That would be general form quadratic, which we'll talk about in a little bit. You could also rewrite these things to be like y equals x squared. That would still be a quadratic. Or y equals 2x minus 5 plus x squared. All of those things are degree 2, because the highest exponent is a 2. I even wrote the last one in a really weird order, but all that matters is that the highest exponent on it was a 2. That should be review. Constants are what you did when math was really easy. Linear was grade 9/10. Quadratics was like grade 10/11. Mainly grade 11. Graphing though. So we're going to practice graphing today and remembering how to find things on our calculators. So the first thing that we always want to do is reset our windows on our calculator, because that just makes our lives way easier. So if you turn your calculator on and you go to Window, it's usually a good idea to start with an X minimum of -10 and X max of +10. The X scale, I just leave it as 1, but that's what you're counting up by on your graph. So I just always leave it as 1. You can adjust it if you want. Y minimum, I leave it as negative 10. Y max, I make it positive 10. That's my standard window. So you're going to hear me refer to like graphing your standard window. This is what I'm referring to. Negative 10, 10, negative 10, 10. It gives me a nice little box. I do have to change from time to time, especially on word problems, but it's just a good little idea of how a place to start. Okay, now let's try graphing something. So, on your calculator in the top left-hand corner, you're going to see a Y equals button. You're going to click that Y equals button. And this is your Y equals. So you're going to type in 5x minus 2 into your Y equals. Make sure that you use a negative symbol in front of the 5 and not a minus symbol. The negative symbol is down beside your decimal button. If you use minus, your calculator will get confused. You use negative, it won't get confused. Now that you've put that into your Y equals, you'll hit the graph button, which is in the top right-hand corner of your calculator. And you should get a line that looks pretty much it's a lot straighter. You should get a graph that looks somewhat like that. If you aren't getting that, now is the perfect time to troubleshoot and ask me or ask someone next to you. Graph should look something like that we have here. Now, we're going to fill out some information about that in our chart to the left. The first thing, the degree of the function. What's the degree of a function? It's 1. Why is it 1? Because that's the highest exponent. So the highest exponent was a 1. So the degree of the function is a 1. Pardon? Oh. Please.
Oh, I was talking about something.
Oh, okay. The number of X-intercepts. It's not even asking where it is. Just how many X-intercepts are here. There's one X-intercept. It's right here on our graph, right? It's whatever crosses this line. So it only crosses that line one time. It's not asking where it is, it's just asking how many there are.
And is that, like, say you were just doing equation, could you still figure that out?
Yep, you can still figure out what it is. Yeah. How many, oh, sorry, not how many Y-intercepts. What is the Y-intercept? So if you look at your graph, it's at -2. If you're not sure how to figure that out on your calculator, you can turn your calculator on. Look at your graph. If you hit trace and then go 0 and hit enter, it'll tell you exactly on the bottom of your screen where that Y-intercept is at. And it is at -2. Yeah. Perfect. And another way to figure it out is there's always going to be something called a constant term in your equation. The constant term is the thing that does not have a variable attached to it. This thing is your constant term. You'll notice that the constant is also your Y-intercept. So if you didn't even have the graph, you could figure out your Y-intercept by using your constant term. End behavior. This is a new term for most of us, not all of us. End behavior is asking, what's the graph doing? Meaning, what quadrant is it coming from, and what quadrant is it going to? So on your graphs, your quadrants go quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This graph starts in 2 and goes to 4. It started in 2 and it goes to 4. It crosses through 3 in the meantime, but they don't care about that, they just care about the end behavior of it. Where does it start? Where does it finish? Where are the ends? When you're doing end behavior, always read from left to right. So if you're looking at your line, go to the furthest left and figure what quadrant you're in. And go to your furthest right and figure what quadrant you're in. And that should tell you where your end behavior is. Yep.
So it's going... No. I don't know.
So, this brings up a good question, because I think I see what you're saying. If I had a graph that looked more like this, if I were to look at that graph right now, it looks like it goes 2 to 3. But if I kept going with that graph, what quadrant would it eventually get into? It would eventually get into 4. So this would still be 2 to 4, even though you can't see it in 4 yet. You have to understand that eventually the end behavior is going to wind up in quadrant 4. You're always going to go from one diagonal to the other. The only time you're not is if you have a graph that's a perfect straight line or a perfect horizontal line. Those are the only graphs that won't go from one diagonal to the other. So you'll always have 2 to 4 as an answer, or you'll always have 3 to 1 as an answer. It's always going to be one diagonal to the other. Okay. Domain. Domain's going to be the easiest thing you do in this class, unless it's a word problem. Domain is asking you what's the values of x that this equation can be. How far left does it go? How far right does it go? It goes forever to the left, and it goes forever to the right. That means x can be any number. We represent that with the words XER. X is an element of the reals. X can be any real number. Range, and I should take right in there so you have it. Domain is x values, range is y values. Range can be a little bit trickier. In this case, it's not. So to figure out your range, you want to ask yourself, how low does your graph go? And how high does your graph go? This one goes forever down and forever up. So that means this thing would be, y's can be any real number. There is no limit on the bottom or the top of that graph. Number of turning points. Does this graph ever get redirected? The answer is no. So that would be 0 turning point. It never curves, it never turns, it never does anything fancy. Alright, that's for a linear equation, a degree 1 equation. We're going to now try a degree 2 equation. This thing is a quadratic equation. So I want you to try putting this into your y equals. So y equals negative 2x squared plus 2x plus 4. Put that in your graph. See if you can graph it. And then we're going to look at our graphs together and then start evaluating things. Alright, so you should have that graphed on your calculator. If you don't, let me know, and I can try my best to help you. The worst thing I want for you in this unit is for you to not be able to get the graphs. You can't get the graphs, you can't do these questions. Okay? It's just going to make your life way too difficult. So let's make sure we're getting the graphs, like practice lots, ask questions when it's not working, don't let yourself just suffer. Alright, first question. The degree of the function. The degree is the highest exponent, so the answer for degree would be 2. Degree means highest exponent. The number of X-intercepts. There's 2 X-intercepts on this one. What is the Y-intercept? 4. What's a really quick way to know it's 4 in? Just look at the equation. The constant term is the Y-intercept. What's the end behavior? So this one's not a straight line like the other one, so it's not going to go diagonal to diagonal. What would it be? It goes from 3 to 4. Like that. So remember, labeling your quadrants. If the top right is number 1, and then you go counterclockwise. It starts in 3. As we follow along, it ends going down into 4. Domain. The domain is the possible values of x. So that means how far left can it go, how far right can it go. The distance it can go to the left is forever. The distance it can go to the right is forever. So that means this thing is XER. It's always going to be XER. Spoiler alert. The only time it's not is if it's a word problem. Okay, that's the only time things are going to change. Range. Alright, now we're getting one that's a little bit trickier. So, your range is not going to be YER. How come it's not going to be YER? Because it stops at the top. So Y is talking about possible Y values. And if you look at your possible Y values, it goes down forever. So that means I can definitely hit negative like 1,000,000 for Y values. But there's a top right here. That's where it gets stuck. So whatever this Y value is right here, it's the same as the Y value right there at the top. We need to figure out what that is, because that's going to determine our range for us. To do that, on your calculator, what you're going to do is you're going to go second, which is the nice bright yellow button. You're going to hit trace, which is right beside the calculate button. And you're going to see a list of options. There's going to be one of those options that kind of makes sense to what we're looking for on our graph. What word on there kind of makes sense for what we're looking for? Maximum. We're looking for the maximum, right? The highest point we can get here. So you're going to click the maximum option. It's then going to say left bound, question mark. What it's asking you is, show me a point on the graph that's left of the maximum. So what you want to do is move your little cursor using your left and right arrows anywhere to the left of this maximum. I would select somewhere over here. And I would hit enter. And when I do that, it's going to say right bound. Now you need to show it somewhere right of the maximum. So I'm going to circle somewhere over here. Then I'm going to hit enter after I've done my right bound, and it says guess. You don't want to guess. After you hit enter one more time, it'll tell you the right answer. So hit enter again, and at the very bottom, you should be getting a value. What's the value that it tells you? It should say X and Y. I'm just going to draw that. What's the X value? 0.49? That's 0.5. What's the Y value? 4.5. That's my maximum point. Another word for it is a vertex. The reason your calculator said left bound, right bound, because that's always a question I get, is your calculator is finding the maximum in the little range you showed it. So we're going to start getting graphs that have more than one maximum. So you're going to get graphs that have multiple turns and waves to it. And you're going to have to find something called relative maximums. So I want to find the maximum in this area of the graph. And I want to find the maximum in that area of the graph. So when it's saying left bound, right bound, you're able to tell it whereabouts you want it to look for a maximum, rather than just the whole graph. Yeah.
A relative. It's like the average, or is
we're going to talk about that in the future, but a relative maximum, if you made a graph that looked like that, the maximum would go forever. but the relative maximum for this area would be right there. So it's just finding like a maximum for that little area. Okay, now that we found the maximum for our actual graph, 0.5 and 4.5, you need to take the y value of that thing and somehow use it for your range. What do we know about our y value? It's going to be less than that point. So we say y is less than or equal to 4.5. That's saying y can be anything underneath 4.5. It can go anywhere lower than this marker right here. Yeah?
Don't you put comma y-er?
You should. You could have it. I'm bad for that. Okay, that was craziness. Alright, well then, let's just redo that. Okay, I saved it somehow there. That was craziness. I just did some magic, I think. What on earth? Wow! I am butchering this. Alright, there we go. Saved it. Okay, so seriously, right, you should get in this nice little habit of saying y is less than or equal to 4.5. And then you do say y is an element of the reals. So that means y can be any type of number that's less than 4.5. So it could be a decimal, whole number, an irrational number, a negative number, it could be anything.
What numbers are not part of
The things that aren't part of real number systems are things like, you know how we say you can't square root a negative?
Yeah.
That creates something called an imaginary number, which is not part of the real number set. So it's something you'll never, ever have to work with. At least I hope.
What do you go into?
Math 30-1 followed by calculus followed by university for 4 years. And then you'll start to talk about it. So you have to be like a math major. Yeah, you don't want to. Yeah, you can't do it with your calculator. You don't want to get into that stuff. It's not fun. Number of turning points. So how many times does this graph change direction? Once. If you look at it, right at the vertex, that's it changing direction. It was going up, all the way up to that spot, and then it started to come down. That's a turning point. Is one of them. So that's what you're looking for, is the number of times it changes direction. It was going up, and then it started going down. All right. 2 questions here. These are for you to try on your own and then fill out. So give it a complete shot. See if you can label your vertex too, because that's going to help you with your range. We look at the first one. So we should have graphed it. X squared plus 2x minus 3. Very first thing is it wants you to find a vertex. When you go second trace, the option you want to pick when you look at your graph, which looks like this, is maximum. Because that's the highest point, right? If you did that, you should have got 3, 9. Negative 9? Did we get different answers? This first one, let's redo it. So, if you graph it, I said your graph faces downwards, I'm wrong. Your graph should look like this. That means you're looking for a bottom, not a top. That means you're looking for a minimum. So in your calculator, you have to put minimum in to be able to find it. The second thing about your calculators is sometimes your calculators give you really weird decimals for some reason. And I can't figure out why it does it. I think it must have to do with the pixels in it or something strange like that. But when I put this in, I get an answer of -1, -4, correct? However, when I actually put that in my calculator, it gives me a value of -1.00001, comma 3.99997, or something like that. It won't always, and you might never experience this problem in your entire life, but you might, and it could screw you up. Negative 1.000001, that's just negative 1. You can round that thing for the calculator. So for some reason, it's going to do that trying to give you crazy decimals, just round it on your own. You should notice that it's a crazy decimal with lots of repetitions. Like this one goes 0000, that one goes 9999999. That's so close to negative 4, just push it up to negative 4. Okay? Number of X-intercepts, you should have got 2. Number of Y-intercepts, there was only 1, and it's at negative 3, the constant. The number of X-intercepts is affected by the degrees, but it's not always the same number. It's possible you could have 3 X-intercepts. We're going to talk about that, because it does affect each other. That's why we talk about degrees so much, and because it's going to make a difference. The end behavior. This thing started up in 2, it went down, and then back up into quadrant 1. The domain is always XER. The number of turning points was just 1. I've left the range blank because I want to fill a range with you guys, because that's usually the hardest one. So the only way you can figure out range is if you figure out the vertex, because these things are related to each other. The Y value of your vertex is going to give you your range. And it's your job to decide what kind of symbol goes in between them. It's always going to be a less than symbol or a greater than symbol. It just depends on if it's a minimum or a maximum. This one was a minimum. That means Y will always be greater than or equal to negative 4. So the Y will be above negative 4 at all times. And like Sarah said, you should put Y as elements of reals. That means it can be any number. All right, the next one. If you graph it, these numbers are a little bit uglier, so you get 0.25, 0.713 as your vertex. Number of X-intercepts, there's 2 of them. Your Y-intercept is at your constant. Okay, remember that term. The end behavior, it started in 3, goes upwards, and then down to 4. So 3 to 4. Domain's always XER. Number of turning points is just 1. And again, this number right here from the range is going to help us build, the number of our vertex is going to help us build our range. It should be Y something 0.713. 7.125. Yeah, you round that 5 up.
But it not really 0.
My bad. I just typed it. It should be 7.1. That's my bad. I wrote.
First, I thought I got it right again, but I didn't.
No, I wrote that one down. 7.13. Take that.
Yeah.
Yeah, my bad. That was me. Now you have to decide the symbol. Is Y going to be numbers above that or below that? This one's going to be below, because that was the highest point. So Y will be below 7.1. Right, so most of this should have just been reviewed for you guys. If you actually in 20-1, one of those questions is the exact same as 20-1. Might even remind you. This is a beautiful little question to follow everything up. So I want you to try all 6 of them. So put them in your calculator. You're going to try to find the number of X-intercepts, number of Y-intercepts, the range, number of turning points, and the end behavior. You don't have to fill out vertex and all that, but you're going to need to find it to be able to do it. Well, most of them filled out. You should hopefully have at least some of them filled out. We're going to go through them together, see where things are right, see where things are wrong. I'm trying to do this through my head so that usually doesn't work out well for me. Yes, yeah.
With the last one, I know logically it's 27, but when I FOILed it out, multiplied 3 and got negative.
Maybe 27? Okay, we can talk about that together, because we're going to do both those ones by hand, so we can see them. Okay, the first one I didn't do, but if we talk about it, if you had f of x equals -1, That's like graphing y equals -1. If you were to do that, you would end up with a graph like this, where y equals -1. All the way to the left, all the way to the right. So your graph would just be a horizontal graph. The y-intercept would be at -1. The range would be y equals -1. It never changes. It's always going to be at that same level, high and low. The number of turning points would be 0. So if you're just wondering what that thing would look like, it's probably good to know what a constant graph looks like. A constant graph is just a horizontal line. The second one, this is a linear graph because the degree is 1. The number of x-intercepts it just has one x-intercept in it. The value of the y-intercept is the constant, so the value is at -2. And this thing does not have a minimum or a maximum, so it's y-ER. There were no turning points. And it started in quadrant 3 and ended in quadrant 1. Next one. 5 minus x squared. You put that in your calculator, you should have seen it had 2 x-intercepts. It had one y-intercept. The y-intercept is at the constant. And the constant is just 5 in this case. The range, you had to find your vertex. The vertex was at 0, 5. And because it was opening downwards, so it had a maximum point, that means y would be less than or equal to 5. It would be below that maximum point. The number of turning points was 1. It started in quadrant 3, ended in quadrant 4. The next one. This one has no x-intercept. So if you're trying to picture what no x-intercept looks like, you have a graph like this. That has no x-intercepts in it. If you have no x-intercepts, you still have one y-intercept. The y-intercept is the constant. The constant in this case is -5. And you're going to have y is less than or equal to the maximum point, because it's everything below that maximum point. The number of turning points is just 1. It goes from 3 to 4. These next two, you can get the y-x-intercepts by graphing them and looking at them. To find the y-intercepts, people mistakenly will call -6 the constant and +0 the constant. Or maybe even -3 the constant. The reason that those are not the constant has to do with the form of the equation that you're looking at. To be able to use the trick we just talked about, you have to be in this form. We call that general form, meaning that it's been fully expanded. There's no multiplication, there's no brackets in here. This thing has to be expanded to be able to find where the constant is. To do that, we want to use an area diagram on a question like this. So if we were to expand that, we'd have x plus 2 times x plus 2, because that's what it means to have x plus 2 squared. X squared plus 2x, 2x, 4. So if you multiply the x plus 2 squared together, you would have had y equals x squared plus 2x plus 2x plus 4 minus 6. Okay, so that's me expanding that binomial squared. Then you have to collect your like terms. So 4 and -6 is -2. That's why my y-intercept is at -2. Another way you could do it is in your calculator, you could go trace, 0, enter, and it'll tell you where your y-intercept is. So if you don't want to do all that expanding, trace, 0, enter. The last one, people would normally mess up that one when it comes to finding the Y-intercept on it. The reason why is because of that 3 out front and the fact that they're negative. So if you want to find the Y-intercept of this thing by hand, you must expand it so it's in that general form we just talked about. To expand it means it's like this. 3, x, right? X minus. Then x minus 3 again. Multiply the binomials first. To me, it makes your life easier. So multiply x minus 3 with x minus 3. You get x squared minus 3x minus 3x plus 9. Negative 3 times negative 3 is positive 9. When you collect your like terms, that means you now have x squared minus 6x plus 9. Multiply the 3 into all the things. 3x squared minus 12x, so 18, minus 18x plus 26. That is your constant value, so that's your y-intercept. Yeah. Zero is 0? Oh. Sorry, how could the range for both these things. Again, you have to find your vertex for both of them, and then decide which way the arrow goes. So for this one where it's x plus 2 squared minus 6, that thing would be opening upwards. So that means everything should be above or equal to negative 6. The other one also is opening upwards, meaning you have a minimum value, so I'd be above or equal to 0. Everything we did today should be reviewed. The only things that were new would be end behavior. So where did it start, where did it finish? Everything else at some point you should have actually seen before. Our next lesson, which is tomorrow, all we're doing is this, but on a little more challenging graphs. That's all that's changing. So up until this point, you've only seen degree 2. Now we're going to do degree 3. Okay? After that, we're going to do something called regressions and some word problems. So that'll be Thursday. Friday, you're going to have a quiz on all this. So my suggestion is that we start studying for quizzes a little bit earlier and start studying for unit tests a little bit earlier. So you should be practicing your 4.1 practice tonight. Then tomorrow, you're good at 4.2, then you practice 4.2 tomorrow night. And then you practice 4.3 the night after that. And instead of letting everything build up, which is what we have been doing, at least what many of us have been doing, try to chunk out the work. It'll make your lives much happier when you're closer to an assessment.